The diagram shows a circle, centre A and radius 10 centimetres, intersecting a circle, centre B and radius 24 centimetres. The two circles intersect at the points P and Q. The radii AP and AQ are tangents to the circle with centre B. The radii BP and BQ are tangents to the circle with centre A. So something that tells us straight away is that we've got right angles here and here, like so. So show that the angle PAQ, which is this angle just in here, is 2.35 radians, correct to three significant figures. Now what I think I might do is just draw out a triangle like this, where this is A, P, and B, and let's call this angle here alpha. And we can find that because we know that this is 24 and this is 10, and compared to this angle, this is the opposite and this is the adjacent, and the angle PAQ is just twice that, is just 2 alpha. So alpha is going to be the inverse tangent of the opposite, which is 24, divided by the adjacent, which is 10. And all I need to do is make sure my calculator is in radian mode. Now I think I used it last time in degree mode, so it might be an idea. Whoops. Am I not getting into setup? There it is. And let's just make sure it's in radian mode. And then I can go inverse tan of 24 divided by 10. And that's 1.176. And then the symmetry just tells me that angle PAQ is equal to 2 times alpha. And so we just need to multiply that last answer by 2, and that's 2.3520, and so on, which is 2.35, correct to the three significant figures required. Find angle PBQ in radians. Well, we know that we've got a quadrilateral here, and so the angles must add up to 2 pi. So angle PBQ would be 2 pi. Take away, we've got two 90-degree angles here. Remember, that's pi by 2. Pi by 2, take away pi by 2, take away 2.35. And 2 pi take away pi by 2, take away pi by 2 is just pi. So I'm going to do pi, take away my last answer, and that's going to be 0.790. Correct to, I'm just going to use the same accuracy as I used here, three significant figures. So the next part of the question is we want to find the perimeter of the shaded region, which is just bounded by these two arcs. So the perimeter is going to be, so we've got this one here, which relates to this angle here, and the R there is 24, so it's just R theta, remember, so it's 24 times 0.790, and then the other radius was 10, multiplied by the 2.35. So we've got 24 multiplied by 0.790, add 10 times 2.35. Oops, I've got double times in there. And that's going to give me 42 point, let's say that's 42.5, and I think it's centimetres, isn't it? Let's just go and check. Yep, centimetres. And again, we'll just say that's three significant figures there. Okay, so what have we got left? Find the area of the shaded region. Okay, we might need to think about this one. So, well, basically, if we look at that, it's two segments, isn't it, added together. So we do the APQ, so APQ, we know the angle here was 2.35, and we know that the radius there is 10, and to get that segment there, we're going to do the sector take away the triangle, and then we've got the other sector, which is BPQ, that looks like a beta, and we know the angle just there was 0.790, and this is 24. So once again, to get that, we'll do the sector take away the triangle. So for the first sector, we're going to have a half times 10 squared times 2.35, and then for this sector we'll have a half times 24 squared times 0.790, and then we've got to take away the triangles. So we'll use a half AB sine C, remember that formula, half AB sine C, and so that's going to be a half times 10 times 10, 10 squared again, times sine 2.35, and take away a half times 24 squared times the sine of 0.790. And we can do that all in one go on the calculator, and that's probably the best idea. So we've got 0.5 times 10 squared, which is 100, times 2.35. So that's in there okay. Then we've got 0.5 times 24 squared times 0.79. Then I'm taking away 0.5 times 100 times, this time, the sine of 2.35, and we also need to take away 0.5 times 24 squared times the sine of 0.790, and that's going to give me 104.86 and so on. So we'll say that's approximately 105 square centimeters.